Welcome to a new AG session all about analytic geometry. Here we are going to determine if the points given A at -3 and -4, B at 2 and -1, and C at 7 and 2 are considered to be collinear. In our Cartesian plane, we can plot all these points. If we're going to consider this Cartesian plane and each of the grids are 1, we can find A in this manner. Of course, we know that our x-axis is the horizontal line. So -3 and -4. This is the point represented by A. -3 and -4. Our B is at 2 and -1 here. -1. This is our B. And our C is at 7. 3, 4, 5, 6, 7. And then 2. 1, 2. This is our point C. These are the 3 points that are identified, and we are to find out if they are collinear. Now, there are 2 ways for us to determine whether they are collinear or not. One of which is using the segment addition postulate, saying that since B is between A and C, a line segment that can be drawn connecting them is a line if the distance from A to B plus the distance from B to C is equal to the distance of A to C. But we could also use here the concept of the slope. We could say that these 3 are collinear if the slope of a line segment that can be drawn connecting points A and B is equal to the slope of a line connecting the points B and C. Since B is already between A and C, this is already okay, but of course you could also verify if the same slope is with A and C. Nevertheless, just for these 2 conditions, or the first condition, we can establish that they are collinear if they are equal. We know that the slope is equal to the change in y over the change in x. Or algebraically, this is computed as the difference of y sub 2 and y sub 1 over x sub 2 and x sub 1. So we simply pick the points and identify which is your first point and second point. For the slope connecting the points A and B, let's consider A as our first point and B as our second point. In short, the y sub 2 is the y ordinate of our B, which is -1, minus our A, which is -4. Please don't forget to include our parentheses here. Over our x sub 2, which is 2, and our x sub 1 is minus -3. The slope connecting the points A and B is -1 plus 4, applying a double negative property, over 2 plus 3, which will give us a result for the slope connecting points A and B be equal to 3/5. Now let's try to find out if this is the same as the slope of a line or line segment connecting B and C. Let's consider C as our second point and B is our first point. So the y sub 2 is 2 minus our y sub 1, which is -1, over our x sub 2 is 7 minus our x sub 1, which is 2. With this, applying double negative property, you have 2 plus 1 over 5. In short, the slope of a line segment connecting B and C is equal to 3/5. Since the slope connecting AB is just equal to the slope connecting points B and C, and as mentioned, B is between A and C, we can now say that the points A, B, and C are considered to be collinear. Thank you for watching, and stay tuned for another session here in AG for Analytic Geometry.